I've always wanted to be a scientist. My mother tells me that when I was 3 or 4 years old, I wanted as a reward for behaving myself that I could do some sums on a piece of paper, and it's a natural progression to become a scientist for me. I'm here at the CSIRO in Melbourne, and I've made a group of materials that could be the magic bullet for bringing efficiency to a whole raft of industries. As much as 40% of the energy that we use in the world goes towards doing a separation. The entire natural gas industry is essentially a separation challenge. Any water that we drink goes through a separation. And so what we're looking at is how can we do these separations better, but mainly how can we do it with more efficiency. We're working with a group of materials that are known as Metalorganic frameworks, or MOFs, the world's most porous materials. 1 teaspoon of this material has the same amount of surface inside it that an entire football field does. That gives us the opportunity to soak things into it like a sponge, or to separate things from one another like a filter. There are heaps of applications for these MOFs. One of them, for example, is storing natural gas in a car. If you fill your tank up with one of these crystals, you can get up to double the amount of gas stored in that same space. We can store hydrogen, the ultimate carbon-free, clean-burning fuel. We can capture carbon dioxide, which of course we want to stop getting into the atmosphere. We can protect our soldiers from chemical warfare agents as well. So once you've got a sponge that the ingredients are infinitely variable, you can tune it up to a specific set of circumstances and away you go. When we're trying to discover metal organic frameworks, essentially we're just mixing liquids together to start with. And when we get it right, we get a beautiful crystal forming. We take this crystal and we can look at it with X-rays, and we can actually work out where every single atom is inside that crystal, what it's doing and what it could be used for. Probably the most exciting moment we had was what I call a "that's weird" moment. We started putting these crystals into layers of plastic polymers. Usually these polymers don't work for a very long period of time, and we found that when we put these crystals into the structure, those polymers start to weave themselves inside the crystals. And so now we've got materials that are lasting a few years instead of a few weeks. And this is a real game changer for the industry. Well into the future, I hope that we're seeing these materials all around us. Maybe they start off in down-to-earth applications like in dairies or breweries. But then going further out, we can imagine that they're applied in submarines. They might even be in spacecraft. Once we've done that, that's just the start. It's really about being limited only by our imagination.